Okay, fine. All of you. Hope all of them are safe. So today in this video, in regard to our testing of materials, we are going to see about what is meant by fatigue. Fatigue is generally is called as a phenomena of material failure of repeated loads. So the capacity of any material to withstand this repeatedly applied stress is known as fatigue. Yeah, defined this fatigue limit is defined as the maximum stress which occurs when a specimen can endure without any failure and the stress is repeated for a specified number of or n. So the nominal stress values that causes fatigue failure are very less than the ultimate tensile stress limit and which will be above the yield stress limit of the material. Fatigue strength of a material is usually tested using a rotating beam machine. So we'll be just seeing about this rotating beam machine in detail now. So methods to determine the fatigue life, we have various methods like rain flow analysis, fatigue damage spectrum, SN curve and minus rule. So this is based upon our stress life method. Apart from this stress life method, we have the strain life method. In this strain life method, we have two methods. Then we call it as a crack growth method and probabilistic methods. So the strain or stress life method. So this is a rotating fatigue testing machine, rotating beam machine, where we'll be holding the specimen at this location and the part of the specimen which is will be in compression and similarly it will be in tension also. From the support will be having an anchor and that anchor will be having the weight on this specimen. So weight will be also is been added here. Similarly, the rotation also will be subjected to this specimen by the motor and the rotation, how much of rotation is being taken place will be determined by the revolution counter on the other end. So this fatigue specimen is just gripped to a motor at one end to provide the rotational motion, whereas the other end is attached to the bearing which is subjected to the loads or stresses. So this is the actual configuration of our rotating beam machine. We have a shaft so which connects a test piece and we have there will be two bearing. From that bearing we'll be having the weight anchor where we'll be adding the loads. On the other end, either on the left end or right end of the any beam condition of our rotating beam machine, we'll be having the revolution counter. So we'll be just counting down how many rotations has taken place for this specimen. So the specimen will be subjected to both tensile force and compression force while it is in rotation. So the specimen is rotated about the longitudinal axis. The upper part and the lower part of the specimen will be subjected to tensile and compressive stresses repeatedly. So these stresses are varying repeatedly at any point on the specimen surface. So the revolution counter is just used to obtain the number of cycles to failures corresponding to the stress applied. So based upon this rotating beam machine, will be getting a SN curve, the numbers of cycles to failure. So this is stress on a y-axis, on life cycles on the horizontal axis. We'll be plotting that curve, so which we call it as the stress versus cycle or SN curve. So the test specimen is just placed on the machine and it is being rotated using an electric motor. When the specimen is rotating, it can be noted that upper surface of the specimen is subject to tension, whereas the lower surface experiences a compression. So as the specimen rotates, there is a sinusoidal variation of the stress between a state of maximum tensile stress and a state of maximum compressive stresses. So this cycle of stress is applied till the specimen gets failed from its surface. So the reduction counter records the numbers of stresses cycles. So for the same material, we'll be doing at least 6 specimens are tested in the same manner under different stress levels and the results are plotted on the SN graph. So this is the thing for each curve, we'll be doing around 6 iterations will be done. 6 experiments will be done. If you consider an alloy steel, heat-treated alloy steel, we'll be doing around for 6 experiments. Then only we can plot this curve of based upon our different stress amplitudes, we'll be getting this curve. So this SN curve is drawn on a semi-logarithmic scale with the numbers of cycles on x-axis required to cause a failure of the specimen on the x-axis and the stress x s on the y-axis. So this SN curve is called as the resulting curve in SN graph is called as an SN curve. So we can have the for different materials we'll be doing the testing. So based upon the materials we'll be plotting the curve. So that type of curve only we call it as SN curve. So during this, at the one end it fails. So that stages in fatigue failure will be having two stages: crack initiation, crack propagation, then finally failure. So you can see the black spot here. So that black spot we call it as an initiation. Slowly the crack will be growing as the stress cycles increases. So that we call it as a fatigue crack propagation. As the numbers of stress cycles increases, will be going the numbers of cycles increases, the failure occurs. So here we have two cycles of fatigue. One is we call it as an high cycle fatigue and the other one we call it as low cycle fatigue. If it is high cycle, it is greater than 10 power 4 at the hertz of 20 to 50 hertz. Low cycle fatigue, N is the numbers of cycle is less than 10 power 3 cycles with the constant strain amplitudes. So these will be getting the results from the SN curve. So that is it is useful while doing our design of our any components. Endurance limit can be identified. So based upon all these conditions will be these are the some of the videos which are been there in our YouTube or NPTEL video series also can be downloaded. So based upon this, so thank you to all of you. We'll see in the next video.